Okay, 1.3 is on geometric sequences. So we've looked at arithmetic series, we've looked at arithmetic sequences, now we're looking at geometric sequence. So arithmetic meant that there was a common difference. You subtracted between two numbers, so term 2 minus term 1 or term 4 minus term 3, whatever it is. And when you had the same value for a difference, then you called it a common difference. Geometric sequence are same thing as an arithmetic sequence. They're a list of numbers separated by a comma, but the difference between geometric and arithmetic is you have a common ratio instead of a common difference between terms. So difference means you subtract. Ratio means that you're putting it as a fraction, so it's a divide. So 2, 4, 8, 16, and 32 are examples of a geometric sequence. We have a comma in between the terms, and if you go 4 divided by 2, you get 2. 8 divided by 4 is 2. 16 divided by 8 is 2. So I'm always going up by either dividing the one term behind by whatever the common ratio is to get the term in front, or multiplying by the same number to get the next term. So 25, negative 5, 1, negative 1/5, and 1/25, those are all common, or those are all geometric sequences, because we're dividing each term through by a 5. In this case, we're dividing by a negative 5. So it says to easily find the common ratio, R, simply divide a term by the previous term. So our common ratio, the formula is Tn is equal to Tn minus 1. So if I'm looking at term 3, then I divide it by term 3 minus 1, or term 2. So in the first example here, if I choose 8 and 4 as my 2, so I divide 8 would be my term 3, 1 less than that would be term 4, so my common ratio would be 2. For the example 2, R is equal to term 2 divided by term 1. So it's negative 5 divided by 25, so it's a negative 1/5. Our formula for finding our term formula for a geometric sequence is Tn is equal to A R to the power of n minus 1. So the term is equal to, A is always your first term, also referred to as T1. R is your common ratio, which is, term 2 divided by term 1, if you want to write it that way. Your n is the number of terms. So nothing different except for that R from your arithmetic sequence one. So it says find the 12th term of 2, 6, 18. So in order to do this, we do the same steps as we did with the arithmetic one. You list all your variables. So I have Tn, A, R, and n. So I don't know, I'm trying to find what is the 12th term. I know my first term is a 2. My common ratio is 6 divided by 2, so it's 3, or I could have done 18 divided by 6 and still get a 3. And our number of terms is, we said we're looking for the 12th. So you write out your formula. So my 12th term is equal to 2 times 3 to the power of 12 minus 1. This is where people make mistakes. My power of 12 minus 1 is only being applied to my 3. A lot of times what people will do is they'll either multiply first. They'll say I've got 2 times 3, which is 6, and then put that to the power of 11. So that's wrong. Or they'll go 2 to the power of 11 times 3 to the power of 11. That's wrong as well. Order of operations says you have to do brackets, exponents, and then division, multiplication. So my exponent here is being applied to that 3. So my 12th term is going to be 2 times 3 to the power of 11, which I didn't calculate separately, but it equals 354,294. Example 2 says 96 is a term in 3236. Which term is it? So write down your variables. So our nth term, or the term we're looking at, is equal to 96. Our first term was 3 over 2. Our ratio then is 3 divided by 3 over 2. So that's the same as saying 3 times 2/3. So that equals 6. Oh, hang on. I did that wrong, didn't I? I did that right, but my math is wrong. So 3 divided by 3 over 2 is the same as 3 times 2 over 3. So 3 times 2 is 6 divided by 3, so your answer is 2. And our n, that's what we're trying to find. What term is this? So we don't know that. So 96 is equal to 3 over 2 times our ratio of 2 to the power of n minus 1. So to solve, the first thing I need to do is I have to get rid of my 3 over 2. So that means I have to multiply by the reciprocal of 2 over 3. So that will cancel. So 96 times 2 divided by 3 is 64 is equal to 2 to the power of n minus 1. So what I need to do here is I need to see, is there 2 to the power of something that equals 64? So you can take out from chapter 5, the square root unit, that table that has the table of squares, cubes, fourth roots, fifth roots, and so on. And you find out that 2 to the power of 6 is equal to 2 to the power of n minus 1. So since our bases are the same, we can drop them. 6 is equal to n minus 1. So 7 is equal to n. So 96 would be the 7th term in this series. Sorry, sequence. Number 3, the 8th term of the geometric sequence is 640 and the 6th term is 160. Find A and R and write out the first 8 terms. When you're doing questions like this, the best way to work on these is to actually take and put out your blank. So it says we have 8 terms in total, so we're going to put out 8 blanks. So we've got blank 1, 2, 3, 4, 5, 6, 7, and 8. So it has told us that the 8th term is 640, so I can fill that in here. And it's told us that the 6th term is 160. They haven't told us what our first term is, so we don't have an A value. And we don't have an R value for the whole sequence here. But if we just look at one chunk here, if we just look at this and use that as our sequence to start with, then we can find out, we can say we have an A value and we can find out what R is. Because if we look at just that part of it, we have Tn, so our last term is equal to 640. Our A is our first term. We're starting at 160. We don't know R, but I know I'm looking at 3 terms. So based on that, having those 3 pieces of information, I can find out my R, and then I can use that R to find the other terms in the sequence. Okay. So Tn is equal to AR to the n minus 1. 640 is equal to 160. R to the n minus 1, so that would be 3 minus 1, so it's squared. So if I divide by 160 first, I have 4 is equal to R squared. So to calculate what R is equal to, I have to square root both sides. And remember, when you square root a number, you have 2 values. A plus or a minus could equal R. So knowing that I have a ratio of 2 or negative 2, I can now figure out what the other values would be. So if r is equal to 2, I've got 1, 2, 3, 4, 5, 160, blank, 640. So I know I have to multiply by 2 in this direction to, whoops, my alignment's off. 160 times 2 will give me my 7th term, so that's 320. 320 times 2 is 640. So now to go the other way, this will be 160 divided by 2. So that'll be 80. If I divide by 2 again, will be 40. Divide by 2 is 20. Divide by 2 is 10. And divide by 2 is 5. If r is equal to negative 2, then my signs are just going to change on here. So this one was 160. This one was 640. So that means to go from here to here, I would multiply by a negative 2. So that's going to be negative 320. If I multiply by another negative 2, that'll be a positive 360. So going the other direction then, I have to divide by negative 2. So 160 divided by negative 2 is negative 80. Whoops. Then I would have a 40, followed by negative 20, followed by 10, followed by negative 5. That's one way of calculating this. So the one way is to find out what is your r equal by looking at those 3 terms. The other way is to set it up as a ratio. So what I could do then is if I say my term 6 is equal to ar to the n minus 1. I have 160 is equal to ar, so that's term 6, so that'd be ar to the 5. Term 8 is equal to ar to the n minus 1. So my 8th term was 640. That equals ar to the 7. So if I set this up as a fraction, I can say ar over 7, or as a ratio, I guess, over ar to the 5 is equal to 640 over 160. So a and a will cancel. R7 divided by R5 is R squared. 640 divided by 160 is 4. So that I'm at the same spot as here. So R is equal to plus or minus 2. So the ratio way will work. You just have to watch your math when you're doing that and remember to cancel out. And you'll get your ratio that way. So either way is fine. Number 4 says, the modern piano has 88 keys. The frequency of notes ranges from A0, the lowest note, at 27.5 hertz, to C8, the highest notes on the piano, at 4,186.009 hertz. The frequencies of these notes approximates a geometric sequence as you move up the keyboard. So as you go from A to C, it's going up by a ratio. So it's determine the common ratio of the geometric sequence produced from the lowest key, A0, to the 4th key, which is C1, at 32.7. So if our lowest key here, A0, was 27.5, then they said the 4th key, so we've got, that was 2, 3, our 4th key here was C1 at 32.7. So this is the sequence we're looking at. So listing our variables, we write down what we know. So we know our nth term is 32.7 hertz. Our first term was 27.5. We don't know the ratio, that's what we're calculating, and we know our number of terms is 4. So you write out your formula. I have 32.7 is equal to 27.5. R to the power of 4 minus 1 is 3. So if I divide, I'm left with 1.18 is equal to R cubed. cube root both sides. So I have 1.06 is equal to r. If you wanted to do this as the ratio one like I did there, then you would set each one separately. So you have T1 is equal to AR to the n minus 1, so that would be 27.5 is equal to A R to the 1 minus 1 is 0, so 27.5 is equal to A. The fourth term then was 32.7, that equals A R to the 4 minus 1 is 3. So if I set up my ratio, I have 32.7 is equal to AR cubed over 27.5, which is equal to A. So my A's cancel. I have 1.18 is equal to R cubed, cube root, and you get 1.06 equals R. So the ratio or the formula will work. Use the lowest and highest frequencies to verify the common ratio in part A. So they said that our lowest, so our first frequency was 27.5. Our highest, or the nth term or the last term, was 4186.009. We're trying to find R, and our N, they said that there were 88 keys in between there. So that's our number of terms. So I have 4186.009 is equal to 27.5 r to the power of 88 minus 1, so 87. Divide by 27.5. I have 152.22 is equal to r to the 87. So on your calculators, and it's usually, you usually have an XY button or square root yx like that, so then you can use that function on your calculator to do it. So I'm 87th rooting these two numbers, or these two sides, so I get 1.06 is equal to r, which was what I got doing my other two calculations as well. So the key with the geometric sequence is to remember that you have to have a common ratio. The number has to be, to go up, you are multiplying by a value, by a common value, or if you're looking at it going from an eighth term to a first term, you're dividing by that common ratio. There's your assignment, and good luck.